Hi everyone, my name is Saurabh Hirani. I'm working as a part of the Site Reliability Engineering team at Autodesk, and this video is a preview of the following talk. It uncovers an interesting problem that we ran into while using the Python grequests module. Before we talk about the problem, let's talk about the use case that led to the problem. We have a daily reporting tool that does thousands of HTTPS gets to third-party services, gets the data, consolidates it, and sends out a daily report. The typical runtime of this tool is around 15 to 20 minutes as it does serial requests, that is, it calls the URLs one by one. The requirement that we had was to migrate this tool from an AWS EC2 instance to AWS Lambda. AWS Lambda is a serverless offering by AWS which provides functions as a service so that you don't have to worry about the underlying infrastructure. This is where the problem started. Now, the constraint under which we had to work was that AWS Lambda has a 15 minutes maximum runtime, which means your code has to run within 15 minutes, otherwise AWS Lambda will terminate it. This means that we had to convert our serial gets to concurrent ones in order to ensure that our report runs in 15 minutes or less. An obvious code change in this case was to change from using the request module to the grequest module. Grequest uses gevent under the hood to provide some level of concurrency. But there were some hidden traps there. The execution speed actually varies and it depends on the other Python modules installed on your system. This sounds a little weird, but it will become clear with this 30-second demo. Now, as you can see, I am running a Python 2 interpreter against which I am running a test program using grequest, which is calling a local HTTPS server. This HTTPS server is introducing a delay of 1 second for a get request that it gets, and we are going to make 10 get requests against this HTTPS server, and the log level is debugged. Now, when we run this program, we see that the connection is opened sort of in parallel, but the next request goes when the previous one gets completed, which means that the requests are being processed in a serial manner. Due to this, the typical runtime of this program is around 10 seconds. So the number of requests correlates to the runtime. Now, if we run the same code against Python 3 without any changes, we will see that the code completes in 1 second. It is actually using concurrency here. So there's a difference between Python 2 and Python 3 with the same code, which means that there is some change in the modules that are installed on the system against Python 2 and 3. We will look at this. We'll do a deep dive into all of these stages. And the interesting part is that we'll use the same program, but a different set of modules and go through the following stages. Stage 0, as you saw, was the one which was a trigger stage, which led to the entire R&D, wherein Python 2.7 and 3.7 may or may not run slow or fast depending on the modules that are installed on the system. In stage 1, we will isolate the environment, use a Dockerized container, use virtual environment, and have a baseline setup. And then we will see that Python 2.7 and 3.7 both run fast. Now that we know there is a stage 0 and stage 1, we'll do a diff between the two, we'll detect the problem, we'll inject latency, and then we will see that both Python 2.7 and 3.7 run slow under a very specific condition, right? And now that we know the condition under which they run slow, we can actually implement the fix. But interestingly, the fix that will be there, it will be a code fix, but it will work for Python 2.7, but it won't work for Python 3.7. And in the last stage, we'll find out why it didn't work for Python 3.7, and then we'll make it work for Python 3.7 by making another code change. All of these stages will be demoed through a Dockerized setup that I have. And during the course of this entire demo, the takeaways for the audience will be that you will gain a better understanding of Python profiling and function tracing. We'll also do a selective peeking under the hood of the following Python libraries: gevent, grequest, urllib3, and socket to gain a better understanding of the problem. I'm really excited to share my learnings as we'll uncover some very interesting scenarios, and I'm looking forward to presenting this at PyCon. Thank you.